Hello everyone, welcome back. For today's video tutorial, I will be introducing our new sensor, that is TCS34903. And to have a better perspective regarding the sensor, let's visit the website, that is controleverything.com, and here we have to search for this sensor and let's see what we got for this sensor. And it's a color light to digital sensor, as you can see, and these are some of its more features described here. Also, you can purchase the sensor from this website. Well, I will be interfacing the color sensor TCS34903 with a particle photon, and I require a particle code. And let's go to resource tab, and here comes the particle code sample, as you can see. Now you can download the code as a zip file from here, just like that. Also, you can have the code from github.com, and the repository there is Control Everything Community. Well, what we require is some hardware so that we can make some connections, and let's proceed further. Now coming to the hardware section, first of all the requirement is of our sensor, that is TCS34903, which is a color sensor. Now the second part, what do we require is a particle photon, and this here is a I2C shield. This shield is available on the website controleverything.com, and the real reason we are using this I2C shield is to make connections easier for the other I2C devices for the connection. Now gently press this particle photon over the I2C shield and then we are done. Now this here is a connecting cable. Now make the connection of the cable and the sensor, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and same for the I2C shield. Now for the last part, what we require is a micro USB cable for the power up function, and gently insert it over the power jack. Then we are done with all the connections, and now what we require is to look over the particle code and let's interface. Now for the interfacing part regarding the particle code, what we require is to log into github.com, and here we have to search for the repository, that is Control Everything Community, and here we go. As you can see here, search for the sensor, that is TCS34903, and here it's a color sensor, and this is the particle code. But let's have a look over the instructions. First we need to fulfill, and it says that we have to log into a particle photon and set up the device, and the steps are being provided on this very link. And let's open up this link so that we can have a better perspective regarding the setup and the connection. Here you note down all the relevant information and do carefully the setup. After that, we have to download or git pull the code, and on the online ID we have to copy the code, and build.particle is that online ID where we have to create a new file, copy the code, paste the code, and then save it, just like that. After that, we have to verify and flash the code on the particle photon, and the code output will be shown in the form of logs at the dashboard, and it's the user logs dashboard.particle, and here we have the relevant output, as you can see on my screen. That's correct. Now get back to the code and let's see what we got there, and it's a .il extension file. Now as you can clearly notice in the code, we have included application.h and spark wiring I2C .h header files, and we have defined the address of the sensor, that is 0x39. We have created some variables here, initialized them, and in the void setter function we have set some variables, just like that. And after that we have initialized I2C communication as master along with serial communication with the baud rate equal to 9600. Now coming to the writing section, we have selected wait time register having address 0x83, and we are sending the command to set wait time, that is 2.78 millisecond, and that's 0xFF. After that we are selecting IR enable register having address 0xC0, and the command we are sending here is to enable access to IR channel, that is 0x80. After that we are selecting A time register having address 0x81, and we are sending the command to set A time, that is 712 millisecond, and max count is 65536, that is 0x00. The last writing command, we are selecting the enable register, that is 0x80, and we are sending the command to power on ADC enabled and wait enabled, that is 0x0p. After sending so many commands, now what we require is to have the response of the sensor back to us, and for that is called the reading part, and to select data register, that is 0x94, from where we are going to get the data. And as you can see, we are requesting and reading 8 bytes of data from that very register, which is IR RGB values. It's a data, and here comes the conversion part of the data which takes place according to the guidelines and the formulas provided in the data sheet for TCS34903. At the very end of our code, we want to display the output on the dashboard. As you can see, we have the infrared and red, green, blue and ambient light luminance, and all the units are in lux, which is the common unit, and it's very simplified and generalized code, as you can see. Now what do we require is to have a look over the practicality, and let's see how it works. Now for the working environment part, first of all the step is to copy this entire code of the particle, as you can see on my screen, and then open up the ID, that is the build terminal ID, and here we have to create a new file and paste the entire code there. We have just copied, and as you can see, we have to first create a new file, and here TCS34903 is the name, and here paste the entire code and then save it. And after that we have to verify and compile the code. It's done, verified, and then we have to flash the code. While flashing the code, we have to check for the magenta flash, which will confirm that code is good to go. And as you can see, we have the magenta flash and the successful notification is here, just like that. After that, we have to open up the dashboard, the user logs link, where we can have our output data to be displayed. As you can see, we have the RGB, that's the red, green and blue values, and the infrared values along with the ambient light luminance. All the values are relevantly constant because there is no interference regarding the light intensity falling on the sensor. But when I place an object over the sensor, you can see the change in the ambient light luminance, red, green, blue and infrared luminance. It's decreasing, but when I bring a light source near the sensor, the values increases, as you can notice. Yeah, there you go. The values for RGB, infrared and ambient light luminance increases, and as you can see, it's still increasing as I move the light source near the sensor. So this is how the sensor responds to the particle code along with the particle photon. Now what do we require is to have a look over the benefits, features and the applications regarding the sensor TCS34903. The TCS34903 device provides color and IR light sensing. The color sensing provides for improved accuracy, lux and color temperature measurements typically used to adjust the backlight intensity and correct the display color gamut. Additionally, it can be used for light source type detection as it reports the IR content of the light. The applications include ambient light sensing, color temperature sensing, industrial process control and medical diagnostics. Now this sensor is available and can be purchased from the website that is called controleverything.com, and you can get the code from the source tab from this website. After that, you can download the code as a zip file from this very site. Also, you can have the opportunity to download the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make any clarification if you have, and for further queries you can reach us on controleverything.com, and for comments you can post your comments on community page. For articles and blogs you can have a look upon instructables.com, and to subscribe more video tutorials like this you can go to our YouTube channel. I hope you enjoyed this video and have a good one yourself. Thanks a lot for watching.